Hello everyone. In this video I'm going to explain how to use some of the calculators that we are using as civil engineer on a daily basis. I will not be explaining all the functions, but some of the common functions that are useful while using the calculator. When I'm saying calculator, we're talking about scientific calculator, and there are many versions available. So for current video I am covering 3 versions of Casio those are commonly available among the students. So the type of the Casio calculator that I'll be covering today, those are based EX, we call them. So you may have different version EX, which has shapes like this. You'll see the diagrams, the screen, and then we have the ES 991 or 115 or even 570 ES, which has some functions its own, and then we have the other versions ES, which a bit less advanced. So we'll be covering 3 of them on the topics that relate to civil engineering. As we know, let's say calculator, it enhances the accuracy of the calculation we have it, and it reduces the time that we need for a calculation, and also allows for verification that sometimes we do check things that we can go back and do the calculation again. So to do so, we will be introducing some of the functions. First, if you look at the calculator, we have all screens. On the screens you will see things. Then it has 2 parts, which is where we call the function, mainly function we have it. Then the bottom part of the calculator, it's numpad and functions. You see the calculators has different colors. Each color would be activated with a button. So we'll be discussing those. Let's say in this calculator we have red, yellow, and at the top you see again here shift and alpha. Those are red to activate those functions. So when we say a button, it might have 3 functions. Let's say if I look at the sign here, the sign, it could be sign, it could be sign inverse, it could be D. Just by knowing how to use the calculator, I'll be able to get any of those 3 functions here. So within the screen, if I look at it, there's a part called input and output. When we type things, it's where we see input, and then when we press equal, we see the output and it. Then we have 2 main keys in the Casio, shift alpha, you will see them here, I mean even here and even here, shift alpha. Those are 2 that will allow you to choose the function within the calculator that you have. Then there's this part here, menu setup, or mode setup. Those are basically we go into the calculator and change the mode of the calculator for a different calculation we have it. Then we have the arrow keys. Those are usually used to go between the calculation that we have it. And then we have those delete and AC, all clear, for the 2 buttons that we have it here. That's common between them, plus the numpad we have it here. So those are Casio emulator. Someone can download them from the website of Casio, and you can have them on your computer. It allows 3 months trial version that you'll be able to use them to practice those calculator on your computer. Now, the first thing that we need to pay attention is what we see on the top part of the screen that we have it here. Now, those are important before using the calculator. Let's say you see D here, math, or for example here some arrows. Those are display option, we call them. In a display option, if I make this a little bit bigger, so we have different indicators. I say S stands for something, A stands for something. Those are important to know before starting the calculation, especially when you're dealing with those degrees in the survey courses or some of the courses that you need to change the degree to radian, especially when you're dealing with addition of angles or calculation of angles. So this is important. When I see D on the screen, I'll say this is indication of degree mode, and I can change it to radian, I can change it to gradian. Now there is, for example, we have fixed, we have scientific digits, math, basically the way that the inputs output calls, statistic, we have it. Those are some of the function, or let's say the indicators that you should pay attention on the top of your calculator. So if I change those, then I will have a different whether output. So the output will be affected by those functions that I have them there, those display indicators we call them. Now those are sometimes in the equation mode. If I go to equation mode, it will change. I mean, if I just try one of them, let's say if I go to here, one of them, you will see that those are part of the things. If I go to somewhere here, I mean, you realize those are at the top. I don't have anything there. So there is a way that I can change the things. Let's say for gradient, so I change this one to G here. Or well, let's say if I have something like this, now this is, I see another indicator fixed here. We will discuss those. It will allow you, let's say, always to have, if I multiply a number, I'll divide it by something, whatever I'm doing here. If I want only the result to be shown in 3 digits, always we call them fixed here. That's a part of here we call fix, a fixed number of decimal places in the effect. Now this is useful for your calculation rather than you doing the rounding. So you allow the calculator to always round up, or round, basically it's not up, it's automatic with up and down to 3 digits, or sometimes to 4 digits. That's basically, you can use your calculator to do so. So let's discuss some of those display indicators before going further, because we need to know some of them. Let's say, how do we get to those display options? We have it here with it's in part of the setup. We have it shift. So look, if I want to click on this button here, clicking directly, maybe the white one we have it, which is the menu. But if I want to, let's say, go to the setup, I have to activate shift here. So if I just press this one here, if I press the shift here, then S icon is active on the top, means that anything with the yellow now, because shift is stand for S here, anything yellow is active. So if I press here, setup will be active. Here again, shift, I can go to setup here. Here, shift and setup. If I look at this, they have different but common things that are available. Let's start with the EX emulator. We have input output. So if I wanted to know to, let's say, this, adjust the input and output of the equation we have it, I can go here, number 1. If I go to number 1 here, input output, what does it say? Is that we have math and math, math input, math output, math input, decimal output. What does that exactly mean? Sometimes you do calculation, you wanted to show like this, say if you say 4/5 plus 2/3, you want it to appear as 22/15, but sometimes you want to show it as what, as a decimal. So if I don't want to see the output as 22/15, means that I'm going for decimal. I mean, with this linear we have it. If I choose the first one, look at the first one, math and math. By the way, here numberings, you use the number on the keypad or numpads to activate it. So if I choose this one here, now if I say 2/5 and say plus 8/6, I say equal, it gives me 26/15. Now I can change this one if I don't like 26/15, but I still love to say do the things here. I can go back to the shift setup, go inputs, then here I'm saying I would like to input math, which is the fractions, but I want the output to be decimal, so I can choose 2 here. So if I do the calculation we had, let's see, I say 2/5, whatever it is, plus 8/6, I say equal, then I see the decimal rather than the fraction I have it. This is another way that if you change to the others, we have it here, let's say linear to decimal or linear to linear, how do those things look like? if I go for 4, let's say here, if I say 2 over 5, it uses this icon. This means a fraction, but it's in a linear format. So if you're, most of the 3 calculators we have, and they have math input output, basically linear input outputs. So those are available the way that you have it. So if I this plus, this is how we're writing it down, 5 over 5 over 6. So this is how it's written in a linear. But if I add it, then it gives me decimal output because I chose decimal. Maybe the most common way to use it is math decimal or math. Depends on the person's interest. What about the other activity, the other calculators, how they are? Let's say in this, when I come to the shift and which is setup we call it, we have the first one, math. If I choose math input, basically it will tell me what is the result you wanted, which is the output here. So it's not like this Casio EX will tell you that input output. It says that first you choose the input, which was math, and then I want the output to be linear, let's say here. So this is again the same way. If I say 2 over 5 or 2 over 5, let's say plus 5 over 8, this is giving me the fraction here. So shift setup, I'm going for math, and I choose 2 to be linear. Let's see if I can, maybe it's the emulator that we have it, but it should usually work with the fraction. And this is giving a bit strange. It's supposed to go with the linear. I say if I try this one here, math, which is the input, and the result I want it to be linear here. I mean, let's see if I try something 2 over 5, 2.5, maybe the fraction divided by 5. Oh, yeah, this is appearing like this. If I try to go back to the math and also math, so if I say 2.5 divided by say 0.5 by 5, it gives fraction. So this is, it's supposed to work in this one as well, but I'm not sure why the let's say if I try something 0.5 divided by 0.5 or 0.6, it's giving the linear. So if I go back here and say I need math, but I need the output to be math as well, then if I divide something, then I will get the fraction. Yes, this is kind of a way that you can force the calculator to show what you want here, the inputs we call it. That's recommended to adjust it once, and then you will get used to it. The second, which is the angle inputs here, the angle. Here you, in those two, the Casio ES, 991 ES and the other ES, we have them. You can see them as degree, gradient, radian, we have it here. Degree, degree, gradient. So you have the 3 of them. Here, all of them inside the number 2 we have it. Angle unit. So you can degree, radian and gradient. You can choose any of them that you wanted. So that if you, as soon as you choose, you'll see at the top like this. So if you go back here, and then you'll choose, for example, radian, you see R, the same thing here. You can just press 3, 4, 5, we have it here. 4 is for radian, so you can see R at the top here. That's important, especially if you're dealing with the cosine, sine, and those things. We will discuss this one. If I say now, if it's radian, if I say cosine pi, it means something. Sorry, where's pi? Pi, it's somewhere here. So if this is, makes sense here, look. But if it is, if I'm in degree mode, I cannot say sine, cosine pi. If I do the same thing, it doesn't make sense here. That does not make sense because pi here, because you are in a degree mode, pi here considers 3.14. However, in the case of it's radian, pi is 180, so cosine 180 will be -1 here. This is why it's important to know when you're dealing with the radian angles, you need to change your the mode of the display to radian. Alright, what else? Let's continue. What else we have on the number format? We have it here. Number format is the way that we show the numbers. So if I go to 3 here, we have fixed, scientific, and normal. So fixed, it's what we use. In here you can see number 6 fixed, number 6 fixed, scientific, and norm. Fixed is what I told you, that you can fix the output to a certain degree of decimals. If I choose 1 here, it says a select between 0 to 9. How many decimals do you want after the dot? Say I want 4 here. So any calculation that I have here, where I do it, it only shows me 4 digits here. That's it. That's called fixed. It's very useful. It allows you to always accurately calculate the result, especially when you have a multiple calculation that connects to each other. So every time you round, you forget to round it, the ends will affect the result that you have it. Please do this one. Fix the calculator on a 4 digits, so always you will have numbers. I'm not saying always 4. Sometimes some of the values are very small, so teachers usually say that, okay, take 5 digits here. That depends on the accuracy of the units, actually, not the accuracy, the units that you have it here. So if this unit is it's millimeter, that will be different if it's kilometer, or let's say so that depends on the units that you have and the precision that you're taking in the course. Then this is the same thing here. So you say 6 and you put the numbers here, and I'll fix the things that we have it here. The same thing here. Then the other part we have it, it's scientific, which allows you, in the number formats, allows you to go into the way that you show with the 10 to power something. If I say, for example, 4 here, it's usually, if I have a big numbers, it's always shows a 10 to power something. This is called scientific word. You can go with this one in case if you're interested in those 10 to power minus plus. Those are usually used in the scientific mode we have it here. And normal basically is what I can go for the way that we have it here, normal case. So sorry, in this part here, those are some engineering symbols here. We have it here. Those are, you can have to see the symbol. I mean, those are some for civil engineering. I'm not sure we will use those things, but in some of the symbols that are available could be used to have a constant values. And most of the calculators at the back, they have symbols with their constants, so they are already stored inside the calculator, so you can use those symbols to get to those constant values, which I will not be interested in for our topic here. So please pay attention to the indicators, so you can adjust those display indicators so that before starting you know how does it work here. Now there is another things before going further. It's the insert mode and overwrite mode. What does that mean? Over the delete button, you have this DEL, you see INS, which is called insert. Now if I'm typing a function, let's say I'll just type something. Now there's two ways that I can change it. You see this flashing icon, it's vertical, so I can change this one into insert mode. If I press shift and this, because I want to click INS, insert. Wait, I'm sure. Let's try it here to see if this is working in this calculator. Oh, it's not working in this one either here. So the mode basically that you, rather than yes, it's working in this one actually. Let's see here. Yeah, it's working, but it's something depends on the way that in your calculator it's easier. It will be shown under the letter. So sometimes I want to change this 5 to 6. I will go to insert, so I can directly. Oh, this is not working actually here. Well, this is. I was trying to say that if it's. Sometimes you will see in the emulators they don't have it, but in the real one you see this icon appearing under the let's say the things that you typed. Here you can just replace with this one, override they call it. This is insert mode. So typical way it's insert mode. This is not that much important to say that, but just to make sure that sometimes you are trying to insert something here, this is what the mode you needed. It's supposed to be like this flashing. If you want to replace, for example, this is to something, this is the mode that you go with it. So it's both are available there. I mean, by default it's under the insert. I think it's by itself is the insert mode we have default one. It might be sometimes you change the setting to the let's say a way that you can replace them. Sometimes I just want to replace this 8 rather than deleting, or for example I want to add something between them. We know that, for example, this is important to know something between here, but sometimes the mode will change to a way that you replace rather than adding. So just make sure you are always seeing this flashing. It's beneficial to get used to one of them. I don't recommend to play between both of them unless you know what you're doing. Just get used to one of them, which is the default one, would be enough for the calculation you have. Now, if you know the calculator can store calculations, variables, and then the answer. Now, most of you know how to use the answer, because whenever I click equal, and this is directly stored in the answer, even if I clear off this one here, if I press answer, I can get back the result that I have. But this is the last answer calculation, we call it. The last one will be saved inside answer here. Now, sometimes you can go back to 10 calculation, just simply clicking here, just simply clicking. Even I press AC here, I can just use the arrow key to go back. I can see the last 10, almost 10 calculation that I had before. So I always recommend that whenever you do the calculation, you can, when I told you that calculator could be used to verify what we've done, so you can just go back to see what you wrote before here. I mean, those are the calculation I've done it so far, so I can see one by one here. Let's say if I do some calculation here, then I'll go, I finished with this one, I'll say sine plus something here, let's say equal. Then I can just simply use this one to go back to the calculation that I have. Those are useful while you're doing exam, so you can see what you have done. You don't need to turn off the I think if you turn on off the calculator, those will clear out. They call the temporary memory of the calculator. It cannot see all the calculations. Some of them can go up to 10, some 15, depending on the version you have with the memory that they have it. This is the second. So we have the first one, which is answer. It saved the last one, and the independent memory, we call it, which calculation that you can see them there. You can add any of them that you want to stay. There is a way that you can store them, but I'm not going into that one. But by default, it can save the last one you've done it. But let's say if I'm not interested to save this one, I'm interested to save this one, so I can specifically choose any of them to be saved in the memory data to recall them, to see what I've done here. Then we go for the last way of saving, we call variable. Now this is useful if you are going to use some numbers later. Let's say I have a number like this, and instead of typing this back again, let's say I have this answer, I want to use it after 3-4 steps. So I can store this one into some variables we have. The variable you see in the keyboards, let's say A, B, C, those letters, means that you can store value into A, B, C, here the same thing. How does this work? Let's say I want to store this value into one of those variable I have it here. There is a function called sto, store. Here is directly the button. In this one, it's in the yellow, so it means that I have to press shift here. Here also in the yellow means I have to press the shift here. Let's say if I want to store this value into, for example, here I want to store this value, and those are very small, but I just want to show how this works. What we do here, I press the store here, store, so you see that there's something on the indicator appearing here. Now I have to use one of these letters. The letters that I have them here, they are in red, so I need to click alpha. So I press the alpha again, and then I can, sorry, I think it's directly will be working, so it's store activating directly. So if I click the store, I can directly press this button which has A over it. You'll see an arrow like this goes to A. In this one here, as a shift store, it directly activate the number, those letters I have them here. I can choose, for example, A here, or B, doesn't make any difference, A. So it tells me the answer has been saved in a variable A. I say here as a shift store D. So what does that mean? Even if I, let's say, clear the things here, after a certain calculation I have it, then I want to use the letter that I saved it before. So I can just simply say that, let's say 2 plus, I want to use the variable that I saved it here. Now it was A. So if I want to bring it back, I say alpha, with the alpha press A, let's say over 5, whatever the calculation I have. So A was stored before for me. So I can just simply use it whenever I need the variable here. This is called storing. You can go up to 6, this is even here 6, even you can have X and Y stored as well. But it's really don't recommend to have X and Y because we will use them for calculation, for equations. It's recommended to have those 6 letters we have it here, so you can store those values into the memory and I can use them. I'm not sure some would it if I turn on and off the calculator, will the value still be stored inside it? Oh, this is something depend on the calculator, but usually it's supposed to stay there. So those are, even if you have the, let's say in this case here, it will appear back, the variable A we call it. So you can store. This is useful when you have numbers that you want to reuse them again, but you don't want to type them again and look for them, so you can just simply store them in the calculator during the calculation that we have. You can replace them. If I want to store another number, for example, by the way, to store that you have to have equal, so it will be in the answer, then let's say store here. Now I replaced A to this number, so you can replace the number to the new number. Whenever you store, it will override the old number we have it. Now this is something that I showed you. Let's say in a calculation you have this number, so you have these two numbers, you want to store them. So instead of writing 10 to the power minus 6 in the exam, you can just simply store these two values, and when it comes here I want to reuse these values in the calculation. So this is the number I have it here. I can, if I save this one into A, I can just say A, let's say times this one, and divided by, let's say B. I can store this one into B. Those two I could store them, so whenever it comes here I can just recall them AB rather than typing it. It's usually saves some time, but be careful. I mean, do not mix the variable because you don't see what you saved inside them. You might check them, but that's a bit risky. You need to make sure you know which variable store which data inside itself. Alright, let's move forward. Let's talk about some trigonometry. To see, we have two functions on the calculator, pole and rectangle. How can it help us like to find x and y or theta and this resultant for coordination, we call it. This is useful sometimes you have a slope, you want to calculate the angle, or you have an angle, you want to find x and y. Those two functions are very useful in the trigonometry. For instance, we have a truss like this. So we have the dimension here, and I'm interested to calculate this angle beta here. Now remember, this is supposed to be a right angle triangle. So if I look at from point A up to under point E, we have it here. That's considered to be 4 meters here and 2 meters here with 6 meters. Then the height is 6 meters. So I know this angle would be 45, yes? But how would I use it? Let's say, how would I use calculator to calculate these things for me? If, let's say, considering alpha here, which is, let's say, point E down, I have 2 meters here, which is in the middle, and then 6. How would I calculate alpha here? So the two functions we have at pole, you provide x and y. If you write pole x and y, the result basically will be what? Will be the length, which is this distance here, the hypotenuse, plus the angle that you have it here. This is useful in the calculation of length of the members, angle that we have it here. So how does it work here? Let me just change this one back to, I believe I can reset everything here. I can reset everything. Those are resetting. If sometimes you want to do it, you can just simply have this clear here, shift, let's say this one, and I can clear everything to bring it back to the factory settings. So if I want to do this calculation, this one we call it here, you realize you have two of this function, pole and rectangle. Here it's in the plus and minus, here again in the plus and minus, again here plus and minus. So you have rec and pole. So if I in order to activate it, shift pole, I can say 2, which is x. Now I used comma here, so the comma is basically the yellow one. Again, shift comma 6. Again, close the parenthesis, equal. It provides here the length of this member, EC, plus the angle I have it here. The angle, which is let's say 71.56. Now you know how to calculate this one with the sine inverse, cosine inverse, but this is useful. You can directly use them. So what will happen if I say 6 and 2? Now this would gonna give the other angle. Yes, you can say pole. Say the pole. Sorry. Pole. If I say 6, 2, the length I'm still getting it, but this time I'm getting the other angle, which is the top angle. We have it here. So whichever the first one coming, this is the angle will be from there to the hypotenuse. We have it here. Let's say in this case, if I, for example, this is the angle I wanted from the short side, so I write the 2 first, so that I'm getting this alpha. But if I want the angle here, I'm writing this 6 first, because from there toward the hypotenuse I want this angle, so I will write the 6, then 2, it gives the angle there. This is called pole, which we can use them to calculate the angle. The same thing here. Pole, you'll do it. Let's say 4 and 5, which usually you see them a lot. 4 and 3 we have it. Then you see the angle, the radius, the hypotenuse is 5, and the angle is what? 36. If you need the 3 and 4, then the angle will change here. So this is very useful to be used, pole. And on the other hand, we have rectangle. Now this could be used even to resolve forces. We have it here. It's I have a force, it's 200 Newton, and I have this angle 30. I know this is called 200 cosine, and this is sine of the things, yes, but I can do this one directly with what? With the rec, which is rectangle. What I need to give this length with the angle I have it. So the angle I'm giving it here, then it will provide the two component I have it here. Let's try it. Say in this case I'm using this one, shift rectangle. I also have a force 200, comma, I have the angle 30, press equal. It gives x, on the x is this much, on the y is 100. So remember that the angle that you're providing, whenever you provide the angle, the x does not mean the fx here. Please be careful of this one. So calculator does not know what is x direction, y direction here. How does it work? You give a force here, which is 200. The 30, it's the angle between the force and to an axis. So the calculator accepts this one to be the x. So when I say 230, indeed this is the 230. So the first one would be this value. This is the x value in the calculator, and this will be y value. This is important to understand. So if I write here rectangle 200, but this time I'm writing the angle between the force and the x-axis, which is 60 degree. Now this time the first one, 100, it's on the x-axis because I provided 60 degree, which is angle between the force and the x-axis. Yes, indeed, this is an x-axis. So please pay attention to this one. The calculator does not know the axes. You need to provide the angle that you have it so that it can give you the answer here. So this even could be used for even calculating. This is supposed to be 90 degree, by the way. Make sure you understand this one. The triangle is supposed to be 90 degree. It does not work with the let's say parallelogram, which the angle is not 90. Okay, unit conversion. It's something that useful. Many students sometimes, due to stresses in the exam, they forgot how to convert units in their solution. So if you want to convert units, you can use your calculator. It's at the back of your calculator. You have all, at least the previous version, the ES, they had those table that it tells you, for example, 1 is converting between 1 to 1, at least 40 unit conversion available there, available that you can convert, for example, from something kilometer hour to meter per second, which is in the dynamic using it, or vice versa. You have it. Sometimes you go between not sure, atoms to Pascal. We have, let's say, from the 2 units kilopascal on the pound per inch square. So you might be able to use those sometimes during the exam, and if you forgot how to convert them, this is available in your calculator. The way to do the EX has an easier way. They made it very easy, but the other ones, the ES one, you need to have the back of your calculator, which is the so please do not write anything on the back of the calculator if you want to use the conversions here, because you need to look at the numbers that you have it to see which one is what. You cannot just guess which number we have it here. But for the EX, it's directly available. So if I go here, this is CONV, so for convert. So if I shift 8 here, this one made it a bit lovelier. Length, area, volume, mass. What do you want to change here? So if I go for the, let's say, area wise, then it tells me that, okay, from this to this one, or that to that one. Or I can go back and then say no, sorry, if I go back, for example, I want to change for the volume side of it. So there are this available, I can change them there. Or I can go for, let's say, some other mass. We have more. If I go down, for example, temperature, velocity, pressure. So if I choose any of them that I can see, this is directly available inside here. You don't need the back of the calculator. You can directly choose from here. Let's say if I choose 8 here, it gives something like this. So you come here and you say 1 kilopascal equal to this one. Or I can even, let's say, change this one to anything that I want. Then it gives me the answer in the output form we have it here. For those, however, how does it work? If I say shift convert, it give me the conversion number from 01 to 14. 01 basically stands for this. This is the table that we have it here. So if I want to do, let's say, this one, I need to type 19 here to go for kilometer hour to meter per second. Well, I'm gonna write here 19 to see if it's working. 19, yes, that's kilometer hour meter second. So I can just type here, for example, 5 kilometer per hour. How much meter per second would be? This one. And that's, if I don't like this one, by the way, I can just press S and D here. S and D shift between the display. We have the same thing here. I mean, if sometimes it's possible to be fraction, you can just play with this one. You can give it to you. So the same thing here. If I go here, this one doesn't have a conversion, by the way. This does not have a conversion, so it's only available in these two. We have it here. The ES does not have it. This is a conversion. Constants available, I told you, but as a civil engineer, we don't usually use those. You might use them, so just make sure those are also saved constant within the calculator you have it. How do we access them? We see here, let's say, CONST stands for constant. So if I go shift, let's see number 7, I see those saved constant within here. Let's say I can choose any of them. 3 told me to see what we have it here. Those are, for me, some of them are weird symbols, but if I say like this, it gives me the number here. For this one, again, you need to have the numbers, the constant number, which is here. So if I wanted to get to any of those numbers, we have it here, then I need to type those numbers here. Let's see if I say Avogadro number, where is it? I'm not sure if Avogadro number, yes, 24. Let's say if I press 24 here to see if it's going to give me the Avogadro number. 24 NA, yeah, that's the Avogadro number. So those are stored in the calculator. I can access them. They call them constant. This one, again, they don't have the constant. The ES, all the ES we call them. Alright, let's move on to the polynomial equation solving. So this time we have different way of solving equations, so we discuss each of them to see. Unfortunately, this does not have solve or some of the equation. It does not have I mean, if I go to here, they don't have the, sorry, And those are the setup we have. Sorry, I believe this one does not have an equation inside. Now this one does not contain, but those are, they have both of them. They have the equation, or solve we call it. So let's discuss polynomial equation solving. Sometimes during the calculation that you have it, you need to solve an equation which might come into the form of quadratic. Yes, you can use a quadratic formula, or you can use your calculator to write this function and solve it within the calculator. So we have two types of the solve we call it, or equations. There are some form available within the calculator. Let's say this is a second degree, or they call them unknowns, whether two unknowns, three unknowns, or you have one unknown but second degree, third degree. Or sometimes you have an equation which is in what they call the second degree or hierarchy. Sometimes there's a formula which does not go into the form of the, let's say, linear equations or non-linear equation. It goes into a different form. So we can use solve three of them. I needed to differentiate between them. So you might have unknowns, let's say two unknowns, they call linear equations. So if the functions are the equations are linear, but you have two unknown, three unknown, means that you have two equations with two unknowns, three equations with three unknowns. Or you have polynomial, which is first, second degree, third degree. Depends on the calculator. Some of them goes up to 4 degree as well. Then we have the other form, which it's irregular forms that we have it. So let's go one by one over the function that we have it here. In order to go to those, we need to find the equation basically. So here, this is this matrix. So if I go down, basically, I see somewhere called equation and function here, which is this part. So here you can move around and press equal. It goes into there. In here, when you press the mode, not shift basically, just the mode of the calculator, you will see here you have 5 equations. So if I press 5 here, you see the difference. Here it says simultaneous equation, means it's the linear equations and polynomial. Here you see 1, 2, those are what? 2 unknowns, 3 unknowns, x, y, z, or second degree x squared plus bx plus c, or x cubed plus x squared plus x plus d equal to 0. I need you to pay attention to the way the equations look like here. If you have two unknowns, it says that a n x plus b n y equal to cn. So the constant will be after the equal. If you have a second degree, third degree, the constant is before the equal, so it's equal to 0. That's very important because when you're preparing the equation, you have to prepare them according here. Because if the number is, let's say, before the equal or after the equal, the sign might change. In this, let's say if I go to the first one, simultaneous equation, it asks me how many unknowns do you have. This one goes to 2, 3, 4. So if I choose 2 here, what does it give me here? Look, here how does it shows to me? It says 0x plus 0y equal to 0. So I'm typing here, for example, 25, I don't know if this will have an answer, equal, let's say I need to write minus 5, it will directly change it, equal to 40. That's 41. Then I'm going for the next one. I'll say 8x plus 12y supposed to be equal to, I don't know, 10. So if I press equal and again another equal, it will give me x is equal to this one, y is equal to this one. This is how these functions work. So this is simply with the way it is. With the equal, I'm pressing equal, bring you back to the form here. In this one, when I say press 1 here, look, you don't see where is the equal here. That's why it's important to know in the first time when you go to the equation, please pay attention to this one here. So the c is behind the equal here, but you cannot see it here. It's like a matrix. So if I write the same thing here, 25 equal minus 5 equal, here I'm writing 41, and then here I'll write 8 1 equal to 10. So if I press equal again here, yes, I'm getting x and I'm getting y. So with the equal, basically I can shift between the equation, the answer I have it. Unfortunately, this one does not have the function inside. This is called two unknown two equations. You can have 3 unknown. Let's say this one doesn't have 4, but this, the EX, has 4 unknown as well. The other one we have it's the, if I go back to the equation mode again, polynomial, I have it here. The same thing if I go to the directly clicking here, so the mode, go to equation, then I have polynomial here, 3 and 4. But remember this time C is before the 0. So if I type here 3, you'll see I have only one equation here because I have only one unknown. It's x squared. It's binomial, it's a polynomial we have it here. In this one the same, if I choose 2, here look at here, there is no equal. The equal basically, we say the numbers we have it is before the equal. So you can just type it like this, it's equal to 0 here. I mean, they did some of this adjustment so that it will make it a bit easier for the users not to make a mistake here. So if I just press equal again here, I can get the answer of x. Sure, this is most probably it's the because of the values that I put them here, but if I put them in the numbers that would make sense, it gives the real number. That was the imaginary number, we get them here. Yes, depends on what we write here. The same thing here, I can just type the values and you'll get the answer that you have it there. Now this is imaginary because we already know that the numbers does not exist under the root we have it here. This is the way that we go with the polynomial and equation. Just please pay attention to the way the numbers or the function is supposed to look like here. Those are two cases. Now here, how do I come back to the normal? Let's say if I even want to come back to the normal ways, I need to click on the mode here. Sorry, I need to click on the mode and choose the first one, computation. One, I will come back to it. Here the same thing, I'll click on the menu, and if I want to come back to the original, I'll come back to calculate here, number 1, and let's come back to the main screen. The other one we have, it's called solve. Solve, it's useful, but it's very important to know how does it work. Solve, you can see it on the here, let's see with the yellow solve. Here we have it here, but this one again doesn't have solve. Solve use Newtonian's way of solving a function. What does it do? This trial. Let's say I have a function like this. This is e to power x minus 15 equal to 0. So if I write the function here, let's say I'm writing this exponential. Is it like this? Or I can believe this is here. Sorry, exponential of x. So how do I write it? I use the letter x here, alpha x. Then I'll say minus 15. I'll say alpha equal, which is the red one, 0. So I'm writing the function as it is here. You see the same thing here. I'll go for exponential. So this shift here. Again, alpha x, then minus 15, then it's equal to 0. Equal to 0. This is the function I have. In order to solve it, I need to activate this yellow, which is shift solve. When I click on the, let's say, press the shift and press the button, which is correlated to solve, this is, it still hasn't solved, by the way. I mean, this one, it shows something like this. Here, shows something like this. It says solve for x. Here, directly says x is equal to something like this. This is not the answer. This is the trial. So it called iteration. It iterates over, it put the numbers there, and it say how close to 0 is it. Let's say minus or negative, positive, then it changed the x accordingly, gradually till it will find the 0 point. This is how this function works. So if you are far from the, let's say, the 0, it will still does not take that much time, because it will take the numbers and it will iterate, it will get the solution. But the problem of the solve is what? If your equation has two solutions, then you might not always get the right one. Let's say in case we're going to use this function here. This function, which is in the RC, you have this one, usually have two answers. So which one is the correct one? I mean, we use logic there, but the calculator doesn't understand the logic. Now, you might end up something like this if you solve. This is one of the problems with solve, because both of them are solution. 2 points we have it. This is a equation, for example, twicely I mean, if you reach to 0, I mean, twice they intersect with the y-axis, so both answers are correct here. But as civil engineer, we know, for example, that does not make sense if I put that much steel into the, let's say, the beam. So this is the correct answer. And let's try, for example, this one. I believe it's best to try this one so that we can, well, let me just try this one, just to see how the solve is working. If I press, how does it work here? Now I need to type something here. I want to say, for example, try with 25 here. So I press equal here, another equal. It tries to go and solve out for me. The x supposed to be 2.7 here. From here, let's say if I say this number try, I press equal, it goes and it finds the answer, x is 2.70. If you put it there, then it will be left minus right equal to 0. Maybe this has only one solution here, maybe one solution. What if I, for example, try again, shift, solve? What if I press, for example, minus 100? I don't know, maybe it will still give me the same answer. But if I try for this, the equation that I have it here, if I type this equation minus, what I was talking about, if I save this value, would be saving some time rather than typing it here. 47, let's say I have x squared, so I write alpha x squared, then plus, so I'm writing 22230 alpha x again, remember, minus 383 10 to power 6, then equal to 0, equal to 0. Now I wrote the function here. If I solving it, let's say I'm giving a number, any number, I'm giving a big number, and I'm solving it, I'm getting 77,640, which is the answer I have it here. Now if I start with another number, if I start with, for example, with 0 equal, I'm getting the 1941, which is the first one. So this is important to know. When using solve, you might end up two numbers. Now I don't know which one will be correct depending on the physical meaning of the numbers. You need to try to see if the number does not make sense, so you need to try different numbers, or at least the expected number. For the solve, it's recommended to at least know what is the expected value that you're looking for, so you can type a number close to that one. Let's say this is for RC, let's say reinforced concrete. We're designing a beam, we're expecting the reinforcement to be close to, say, 1,000, 2,000, 3,000 millimeters square for the area of the steel. So when I'm solving here, shift solve, the number that I'm inputting, the first one, is important. I can just type 1,000, I'm expecting 1,000, and it gets the answer to me. But if I type something, let's say 20,000, which is very far from the real number that I have it, I'm getting the second answer. Or still I'm getting this answer, but so if I'm going for way bigger numbers, shift solve, let's say I'm typing something here, if maybe this time I'm getting the other answer. So which solution is closer to the starting point, that will be shown in the solve. I need you to know this one. It's useful, but it might lead you to the answer that you're not looking for. So you need to understand the answer, whether it will be logical or not. It's your decision here, not the calculator. That's the solve button we have here. Those are some system of linear equations. We discussed them, so you can type them into the calculation we have. Alright, let's move on to the vector calculation. Now also we in static we use vector calculation, and the calculator also can do vector for us. Now where does the vector goes here? You might see them, let's say not the 300 ES. This one you see number 5, above number 5 you see vector here. This one, it does not write directly vector here. They have it within the menu, for example. If I go down, there's somewhere that you will see the vector. This is basically number 5 here. So it's vector calculation, we have it here. What can be done in the vector calculation? You define some vectors. So here you can define 4 vector. in this one, if I want to go to vector, first I need to change the mode to a vector calculation. If I'm not wrong, number 8 we have it here. So first you go for the vector calculation, then here you can only save 3 vectors. So vector, let's say here I have a vector, I can save them inside here, whether it's a let's say 2 by 2, 3 by 3. I don't know how much is the capacity of the calculator, but whenever you press any of the vector, let's say I want to save something in vector A, I can say A here. It tells me how much is the, well, let's say I'm going for 2 here. So I have 2 digits here. I can write, for example, 600 cosine 30, 600 sine 30, or I can write, for example, minus 400. I can use the pole before to get to those things. Remember, in this way I can use the pole function to get the 2 component of this one. I can use the pole function to get the 2 component of this one. Then I can store them in the vector. Then I can add the 2 vectors together. So I can use the pole function, remember, which also rectangle, pole or rectangle we call it, and I can use the rectangle here, the rectangle to get to the components here. I'll write 630, I'm getting the 2 components, and I'm writing 445, I can get the other 2 components. Then I can store them in a vector form, and then I can do the calculation. For example, we have it here. I'm not sure how much this is if I'm just typing here, but let's say I'm just typing any vector I have it here. This is vector A. So if I'm going to, for example, for this is already saved in vector. Remember the indication called vector. If I want to see the vector, I don't need to go back to the setup. I can press shift and number 5 here, which is vector, will bring me back to the vector. So I have vector, for example, B here. Vector B, it's nothing saved inside it. So I have vector A, which is saved there. So I can say vector A squared. I can square vector, I believe so. But let me make sure that I've saved the vector. So if I say vector A, yeah, vector A is basically, I have it here. Let me store another vector. So if I'm storing a vector, I need to go back to the vector, and I'm storing vector B. Let's say again the same thing. I'll put a number here. Let's say equal. So I have vector B as well. Now I can go to shift 5, and then maybe I need to add vectors together, take the dot product of them. So I can say 3, this is vector A. I can say times or plus vector B 4. So I can just give me also in a form of vector here. So it does the calculation. You can do I don't think so cross product is available here. We have dot product. Yes, this is the dimension we have, but I think I can take the dot product basically. So if I say dot product, I think supposed to be reverse of each other. I'm not sure it makes sense if I do A and B here, but let me try. So if I say vector A, which is number 3, and I go for dot product, go back here vector, and I'll say dot product, can go back there to vector, and I'll bring vector B, say equal. It gives me the dot product with 2 vectors that we have it here. So this is some of the calculation we have with vector. You can do it here. Same thing if I shift for this one, for the calculation, as if I do 1 here, dimension, you have it, you give the answers, let's say. So how do I do the calculation here for this one? It does not have this vector basically here. It doesn't have the vector here. So if I press this one, let's say vector, it brings me to the same defining vector here. It does not directly give. So if I press shift and this one, it still does not. So this does not have directly the way that you see the vectors, the way that you do the product basically there. This is a bit different than this one here because it has number 5 here. If I'm not wrong, the way that we get used to this vector calculation, we have matrix, let's have in a vector form. So let me just have another vector here. So we have the vector saved inside the. Now using them basically, it's in a form of a vector we have it. So if I call out the vector, we have it here. Oh, I believe it's supposed to be in the complex function results equation decimal and symbol. Forgot where is exactly this one. They've changed it to a place that you will get to the way that the vectors would be found. Sorry, I forgot this one. I've never used this one. So this is the part here, which because they removed the vector on the 5 here, it's somewhere within this within the setup they put it, that you need to go and find the in order to call them back. Remember, there was two ways. Was saving it. Saving it directly here, so you can go to the vector and save the values, but reusing those basically is where that you, because this is saving, it's defining a vector. So if I just define here, I can just type them. This is not what we're looking for. You can just define them, but reusing them, it's where it goes tricky here. I used to know it, but long time I haven't used this, so sorry for that. This is where I will leave it for you to find out where is exactly those vectors that you can call them back in order to do the calculation. We have it here. Anyway, we will continue with the others. We have it. Those are the dot products. Matrix calculation are also available in there. So the matrix calculation, the same thing, we have it here. Those are we have, I believe this is the matrix calculation here. We have matrix, the same thing. In this case we have the matrix calculation. If in case you want to use matrices, they say multiplication of matrix, the same way it's working. Inverse of matrix, we have it. Let's say I'm defining first the matrix, well, with the matrix that you have it here. Then let's say those are not all type of matrix available, a certain type of matrix available here. So if I go, for example, for the first one or the second one, it provides the matrix that we have it here. So after defining the matrix, let's say you will go the same way to do the calculation. So first, saving, it's inside here. You always go to matrix, you define the matrix, you have it. Then if you finish defining, then you go back where? In here, number 4 here, shift, let's say here. Then you can say you will get the, let's say if I get the determination of matrix A, which I defined it. So I can, in dimensions error, we have it here. Maybe I need to be in difference here. Shift matrix. I can go for I don't know, say number 8. Shift matrix A. If I define matrix A, then I can see I can get the answers of the matrix. Transpose, basically, that was I was doing it. So depending on what the calculation you have it, it's not that much comprehensive, but you can do some simple calculation there. Maybe, for example, multiplication of 2 matrices that you have it, or addition, or transpose of them, or determination. It can do some of this calculation. I still wonder what was this, how do I get to the calculation of this one? This is because it's available, again, the matrix is not available here, so you need to get it from the, basically from the mode we have it here. Somewhere within here you're supposed to be available. Not sure. Calculate complexes, base n, matrix, vector. That's the defining vector, we have it. Yes. Okay, anyhow, let's continue with the other part of the calculator, which is the angle calculation. Now for the angle calculation, I'll go back to the computation mode, and here I'll go calculation mode, we call it. Now the same would work with the older version as well. So when we're dealing with the angle calculation here, I need you to pay attention again with the display indicator on the top, so that you know, for example, what you have it here. Let's say when you have degree, radian, gradient, so you know what you're dealing with. Why this is important, let's just look at some calculation that we do. Let's say here, if I want to convert between a degree to degree, I can directly use these indicators here. So remember, the indicator shows, let's say, the output, or what you directly put inside the equations. But sometimes I can put a symbol. You see there is a symbol here, G, basically. Now this means that 100G, it's in a gradient basically, it's equal to 90. I can even write like this, this is sine 100G. I'm still in the degree mode, but if I want to write any other angle, I need to use the symbol of it. Look, I can write sine pi over 2, but I need to add this symbol here. But I'm telling the calculator, even though I'm in a degree mode, but this is a radian angle, so please take care of it. You are in a radian mode, I want to use 90 degree, I can write it like this, sine 90 degree. Or I can directly sine pi over 2. I'm getting it like this. I can say sine 100 gradient. I'm getting the same answer. So you're in a gradient mode. For the gradient, you don't need to write anything. But if you use any other angle, you need to put the symbol there. 90 degree, pi, which is radian. Which means that it allows you to work even with the same, let's say, indicator, but you can use the other angles within the calculator. So there's something that this is where we use basically to put those the degree that we have it. If in the degree modes, you can use this one to put those, we call them the degree, the minutes, and the second. Basically we have it here. Now see, if I show some of this calculation on the, you see how does it work. Let's say we are in a degree mode here, yes, in degree mode. What does it mean? If I say cosine, I have to write 90. I don't need to put the degree here. I don't need to put, for example, any degree over here. I can just say cosine 90 is equal to 0. I make it sine so that we can see. So if I say sine 90 here, it gives me the answer. I don't need to say it is degree because I'm already in a degree. But if I say, we say that pi over 2, I cannot say this is wrong here. I cannot simply say that pi over 2 here. That's wrong. Why? Because pi over 2 is radian and I'm in a degree mode. How can I do this one? If I don't want to convert this pi over 2, I come closer to the number here. Then there is this over the answer, you see DRG, the degree radian gradient basically they call it. So I can say shift this one. It allows me to use the symbol. For example, I can choose 2. I'm telling the calculator this pi over 2 is radian. Please convert it to the degree because I'm in a degree mode. Then use it inside the sign and I'm getting the answer 1. And this is true here. For example, I want to convert pi over 2, pi over, let's say, 8 to what? I want to, if I press here, let's see, this is wrong. This is not a degree. Why? Because it says 3.14 divided by 8. I don't want this one. I want to convert this one to how much degree would be. So I need to add the symbol. So shift here, the answer. Then I'm saying this is radian. So if I press answer here, it gives me the answer. This is the angle here. Because I'm telling the software, the calculator, pi over 8 is a radian. So I can, whatever calculation I'm doing it converts back to degree because I am in a degree mode, remember. So whatever you do, if you're in a degree mode, you need to use this symbol if you're going to use the pi or gradient. If I'm changing the mode from here, for example, sorry, into the setup, we have it in the setup. If I go to radian mode here, now I don't need to use this radian anymore here because the calculator by itself understands that this is a radian, so it calculates for me. But now I cannot use 90 here. That will be wrong because 90 is not radian, so that's a wrong thing. How can I do that one if I don't still want to change this 90 to a, I don't know, let's say how much is this gonna be in radian? Yes, I don't want to convert it, multiplied by pi over 180. I don't want to change it, so I can just say 53.48. But since I'm in a radian mode and this is not radian, so I'm going to click on shift degree and I'll say this is a degree number 1. That's also works here. Let's say in this case I can write the same thing to see sine 53.48. It's supposed to give me the same answer because I'm in a degree here. I don't need to put anything. I'm in a radian mode. I need to put a degree sign here. So if I wanted to, for example, convert this 53.48, let's say, to a certain type, so I can first go to that angle. I say I want to go to radian, then I can just simply say, I cannot say equal, it will be the same. But if I add the symbol here, since I'm a radian, and I add the symbol here, where is the symbol for this? Okay. Give a symbol here, they changed it, it's not inside here as well. Recall. No, they shifted inside the engineering symbol. I have it here. This is when we have it here. Still cannot find where those symbol we have it here in this. I think it's okay, options. I found it. That's where basically the option is, the angle unit. Even for the vector it was supposed to be here. So angle units, so I can say this is a degree, I have it here. So if I press it will change it back to what I have in the radian here. So this is how the supposed to work basically here. This is let me change back to the mode of number format. I'll go for norm basically. I'll go for norm here. Sorry, let me reset all of it. So if I'm going back to the mode, we have it here, which is the angle mode. So I'm going for radian here, then I'm writing this one 53.48. You go to option here and say angle units. So this is a degree basically, so it's supposed to give me a radian. That was due to the scientific way that was showing like this. This is the way it works. By the way, for the matrix calculation, this is where the option they put it is, so you can see the calculation of matrix and vector within here. If I'm not wrong, just to be sure that if I go back to vector, then it doesn't make any difference any vector I have it. If I click option, yes, this is the option here. It made it one button that changed based on the vector or the mode basically. So you can use this one, whatever the things available here. You can dot products, we have the angle, unit, vector, I mean all the options that we have it that will be available within here. So go back to the angle mode, we have it here. So to clarify this one here, if you just pay attention to what is the indicator you have it on the top, then you know which angle you need to use. I say you can keep it in the always in the degree mode, but whenever you have an angle which is radian, then you can, let's say if I have 0.98 is radian, I can just simply add the symbol of radian over it, then that's it. So this way you can always make sure you do the right calculation here. Whether you can convert let's say the degree directly or within the equation you have it. By the way, there is this icon here that you can click on it. That's usually useful for survey student, that you have angles in this way, degree, minutes and seconds we have it. This is the button that you have it here. That's changing, for example, the numbers that you have it into this format that you have it. While typing, by the way, you can use the same thing. For example, if I sign 25 degree 45 minutes and 10 seconds, I can use the same thing and it will give me the answer. So if I want to convert this 25, let's say if I'm writing like this, sorry, let's change the mode of this one to degree. So if I write 25 degree 45 second and 10 minutes and second, by the way, they look all the same, but how does it work? If I, for example, in the input you will see there are different. I can press this one, this will change it back to the normal, which is 25.75. If I click this one, it will turn back to the degree minutes and second format. That's useful sometimes in the survey. You deal with those type of angles. We have it here. I believe this is for the angle would be enough. Then we have definite integral. That's useful sometimes for students who do the let's say deflection calculations. Sometimes you have an integrals, but definite integral, and you need to, for example, provide the function here. So if I'm just doing something like this, I will write the function, we have it here, and then do the calculation. So for example, if you write this function here, which I highlighted here, 200, you write the same way. For example, 200x times, let's say, parenthesis, I'm writing minus 5. Okay, just multiply it, but anyway, so put this one into the parentheses just to look like the way we have it there. Now if this is the by itself, and then you type the boundaries that we have it here. The boundaries that we have, which is starting from 5, and then we have, let's say, starting from 0. I can add 2 in the beginning as to look like exactly what we have there. So if I have an integration like this, I can type everything and press equal, and it will give the answer that we have it here. This is useful sometimes when we do the calculation for deflection or some other integrals that you have definite integral. You can type it directly. I mean, those are constant, so those sometimes you can just keep them out of the integral. This is useful. We have I believe here also available, but this one does not have, but this one also the same thing, we have it. I believe it's available for definite integral in this as well. I believe so. I'm not sure if this one has definite integral or not. Depends on the, this is the, yes, they have it directly available here. This is definite integral. Derivative also available, so a derivative also, it's possible to do it. Derivative of function, but this is again with an val definite basically. So if I'm saying, for example, x square, but I need to provide, for example, x how much it is. So it calculates derivative of this function at x is equal to 4, so it calculates for me how much it's going to be. It's possible to be used. I think the last things I'm going to explain is linear interpolation. We have different type of interpolation in the calculator, but the one that's mostly used is a linear interpolation. Before doing interpolation, you need to know that this, sometimes you see people are using this type of equation. You want to find a certain y value for a certain type of x when you have some information. Let's say I have x0, give me y0, then I have x1, give me y1. So how much will be y for x at this point here? This is called the linear interpolation. The calculator have different type of interpolation. So this is the way that providing here, how does this work? Let's say it's in the statistics because it's considered with the statistic calculation, we have it here. Then you need to have some inputs. You'll give the inputs and then you will type away. Let's say an example, if x is 0, y 10, x is 10, y 20. So I want to calculate how much y is for x is equal to 5. What we do this one, how do we do it in the calculator? It's you go to the statistics here. So statistics is where we go. For here, I'm clicking here, we go to statistics, then you see there's different type of equation we have a day. What we're going, for example, linear, it's here, y is equal to a plus bx, 2 we call it. In this one, if I go to the, let's say, mode of the function, we go for statistic, which is number 3 here, number 3. Then again, I'm choosing 2 here, a plus bx, which is the linear interpolation we have it here. Believe this is also available in this one here, so I can go for statistic here, 2, and then again 2, which is linear interpolation. So you look at them, it provides what? It asks you, give me the information. Let's say in here I'm saying x is 0, we have x 10, we have 2 these values. I'm not writing the other one, I'll type the information. This is the known information. You need 2 points for interpolation. This is important. Here again, the same thing I can do. I'll say, okay, 0, I can use the equal sign 10, then I'll type the y value 10 and 20. Will be the same thing for here. Now first you save the data. This is first after changing to static, you choose the linear, you provide the data you have it, and this data will be saved in the memory for the calculation we have it. So you can press AC here because you need to get rid of this one, so press AC here. Now here, because it's statistics, so you can see it here, we go to option here. This is where we go. For this ones, for those two, you have statistic over number 1 here, the same thing here, number 1. In order to do the linear interpolation, you type the value that you want. For example, I want to calculate y value for x is equal to 5. So I'm typing 5, which is the x. Then I'm going to option here. Then you go for the data regression. If I'm not wrong here, let me check data here, the symbol. Nope. Go back here. Option. We go number 4. Yes, number 4 regression, and number 5 is what I'm looking for. This symbol is what we use for the interpolation. Number 5 here. So it looks like this. Here I'm typing 5. I'll go to shift number 1 statistic, then we go for 5 regression, and then I'm looking for this one, number 5 again. This is the symbol we have it here. If I press equal, it calculates y value for x is equal to 5. The same thing here, and it's the same thing. So 5, shift 1, go for regression, and then number 5 is what you're looking for to do the interpolation. This is, it could be done for other type of the function. So you choose other functions and you input the values, then you come here, you will do similar, then you will do you'll get the interpolation, we call it. Remember, this one is in the option here, this type of the function. So you type, let's say I want to calculate for what? X is 34.5. Then I'm going to into option, then we go down, we have regression here, then I'm putting number 5 here. I'll say equal, it gives me the answer. Here if I do this one, 34.5, shift 155, and I'm getting the same answer, which is supposed to be. This is useful for whenever you need a linear interpolation. So you have two data which you're supposed to input into the calculator, then to do the interpolation. If you ever want to change the data, from here you can directly go here and change the data this way. For this one you need to go back to the statistic, choose the things, and then input the new data here. This is how these two work. So if I want to change the data, I'll go back here, go back to number 2. For example, I'll say 4, I have 14, then I'll put the values for this one, whatever the values for y we have them. So I'm having those two values, then I'm pressing AC, then any numbers I want to calculate for it, I can just simply go and calculate the interpolation for this number we have it here. That's the end of the explanation that I have it. There are many more things could be done with this calculator, but those are the main options that if you master them, it will help you in the calculation you have it. You might be able to find many more videos available on Casio, their websites, or other videos that explaining other functions we have it there. Thank you very much.